My name is Chris Perko. I'm an engineer at Hero Devs. We work with companies migrating from older applications, older AngularJS versions, up to new Angular. I'm currently working on a .NET WinForms application built in the 2000s and migrating into Angular. So it's a lot of fun doing some reverse engineering and trying to write that in a reactive way. Also recently a Google Developer Expert in Angular and the director of the Angular Community Meetup. On December 10th, we're going to have an event in the middle of the day. I think it's going to be 1 p.m. Where we're going to have like a panel discussion. I think we're going to have Jeremy from the Angular team talking about the controversial new template things that they've been talking about, like NG Poland and whatnot. So yeah, if you want to join and be able to ask questions, check us out and join the Zoom and be able to kind of hear from Angular as well as some other GDEs and ask some questions. Today's a pretty special day. Angular 19 just released like half an hour ago, I believe. It was just released on NPM. This QR code will take you to a YouTube premiere that's happening, I believe, at noon today, where they're going to be talking about all the new features of Angular 19. So I think those are usually about 20 or 30 minutes long. So yeah, happy release day. So before we get into Signal Store, I want to talk about what signals are in Angular. Prior to signals, we've always relied on Zone.js, which is a library created by Google for change detection. So moving to signals are a reactive primitive that come out of Angular core, and it'll allow us to go completely zoneless. And you can actually currently go with an experimental zoneless build to see how it affects your performance. It is experimental, so don't try it in production. So a basic signal is kind of like we would normally say the count would be just a 0. It would just be a number. We give it this signal function with a default value. And the way this works is inside our template, we normally do an interpolation, but we use the parentheses to get the value out of the signal. So what this does is it allows Angular to really know exactly where in the template these signals are being used. And when the signal is updated, it knows where it needs to update, as opposed to just saying, if something changed, we need to redo all these components, re-render them all. It can be a lot more specific into where it's re-rendering. Signals can be updated in a couple different ways. One is a set method, which just sets the value. And the other is an update function, which you pass it a factory function with the current value, and you return the updated value. So this example just creates a button. We just update that value, and it's incrementing and re-rendering the number on the DOM. So when I talk about state management, I'm going to talk about a specific application I built. This is using Material 3, Angular Material with Material 3. So in here, we have a shop. You can buy some fun things I remember from my childhood. We've got a toolbar at the top, and I know it's probably hard to read on the screen, but there's a little cart icon and there's a badge, and it shows the number of items that are currently in the cart. And as we add or remove items, it'll update that value. So we need to have some kind of state management that allows these components to all communicate with each other. On the cart page, you can remove items from the cart, and there we go. It'll update the total price at the bottom. So we need to know what items are in the cart. We need to update that value when items are added or removed. And again, this is updating the little badge on the toolbar. So we looked at our component hierarchy of this application. We have our root application component. It's got two children. One is a toolbar. One is either going to be the shop or the cart, depending on which route you're on. And then below there, you have each item that is available for purchase. So when an item is marked as either added or removed from the cart, it needs to event emit using an output emitter up to the shop component. And the shop component then has to pass this up to the application component. From there, it can update the toolbar with the changed value. So this creates a problem where the shop component works as like this middleman, and if we replace it with the cart component, you have the same exact issue. So what happens here is in a small application, this is really not an issue. But if we are in a much larger application, you can imagine multiple components have to keep bubbling up these events all the way to the root. So what we would like to have instead is this store that exists outside of the hierarchy that can be injected into anywhere within our application. For instance, it could be injected right into the item itself, and we mark that item as added to the cart. We tell the store, and now any other component that has it injected can subscribe to those changes and reflect the change on the UI. So this introduces us to dependency injection. There are two ways to inject a dependency into a class. There's the classic way of using the constructor, where we just specify what service we're going to inject, and it does it for us. And the new way, which I believe was introduced in Angular 14, is using the inject function. The inject function allows us to use things like functional guards and functional interceptors, and that we don't have access to a constructor. So that's the recommended way to do it. I know some people still like to do the constructor way because they like to do testing. Is that a ghost? So some people like to do testing without test bid, and they just want to new up the component or new up the class and do some class testing. Angular team recommends just using test bed because there is a small performance hit, but you still have all the inject functions that you can use from there. So on our service that we want to inject, we add this injectable keyword or injectable decorator that allows it to be injected into the class or into the component. And when this component is created, it needs to know where is my instance of the service. It'll first look in the providers array. If it's there, it'll new up a new version of that, a new instance of that service for this component. So this is handy if you do want a new service that is tied directly to a component, or you want it tied to your feature, anything below it. If it's not there, it'll look in the parent component to see if it's there. And if it's there, then it should have already been created and it'll get that instance. And it'll keep going up the hierarchy until it gets to the application root. And if it's not there, then you'll get an error saying that it can't find it. If we want it in the application root, we can just provide this provided in root on our injectable service. And that'll create the service as a singleton. So it'll be created, and once this component boots up, it'll find that instance of that singleton and use it there. So a great way for sharing data across components. So Signal Store is going to take this idea of dependency injection and signals and kind of wrap it in a way that makes it easy to compose and also like a structured, opinionated way so that your team doesn't all do things differently. Because you could certainly take a signal, put it into an injectable service, and do a signal as a service type thing like we use with behavior subjects now. This just kind of gives us some more structure. So if you're not familiar with NgRx, they provide state libraries. NgRx state is kind of what everybody thinks of when they think of NgRx, which is the Redux style. And if you've used it, you probably are thinking like, oh my gosh, there's so much boilerplate. I hope they don't do the same thing for signals. And they didn't. Signal Store is much easier to use. So to get started, we're going to build a store for that application where we had the items to buy. First, I'm going to define our state. We've got two things. We've got our status. I didn't really show this in the animation, but at first it shows like a little loading indicator, it waits a couple seconds, and then once it loads, we go to a complete status where we show the items. And then we have our items themselves, which is just an array of these store items, and that class just has like a Boolean, whether it's in the cart or not, title, price, image, things like that. Our initial state, we're going to start with a loading status and an empty array of items. And then we're going to use a signal store function. The signal store function returns an injectable class. So it's kind of interesting. It's using a functional programming way to return an injectable class that works with Angular. And in this case, we want it to be provided in root. So we have a singleton. So we just add this this configuration object, provided in root. And then we use with state to define our state, which is the status and the items. And I should have put those arrows up. So what this does is it creates signals for us. So the status, which was in our state, is created as a signal of type error, complete, or loading strings. So we can use it in our template to see if this thing is loading, if it's completed. And our items are also created as a signal of store item array. So everything you put in state automatically becomes a signal, and you can use it within your application. So how do we update this? Because we need to be able to add and remove items from the cart. Signal store comes with this with methods function. And what this does is it takes the first parameter is the current store, so we can get the current state and do things with that. And anything after that, you can actually use the inject function to inject other dependencies, other services that you might need to use within these methods. So for adding an item to the cart, when we update the store, we need to do it in an immutable way. So we need to create basically a new copy of our items and update it completely. So in here, we're going to take our items, we're going to spread the current array, and again, we have to use the parentheses to get the value out of the item signal. And we're just using an array map to find the item that we're adding based on the ID and switch the in-cart boolean to true. And then we take that new items array and use it in the patch state function. So patch state, again, takes the store as the first parameter, and then a function that returns a partial object that matches the state. So in this case, we're only telling it to update the items. We're not doing anything with status at all. It knows to just update the items in the state. Remove from cart, same thing here. We're only setting the in-cart to false. This could definitely be simplified into one function where we pass in like a parameter of true or false. Just want to kind of be verbose to kind of show how we're using this. So within our component, we can just call the methods directly on the store that's injected. Not much to say about there. But because this is updating their state, these signals that are being used within our application, they will re-render when values are changed. So entities are a really cool feature of signal state. Everything I've shown up to now, you can just do with signals inside of a service. But you get some extra goodies when you work with NgRx. So entities allow us to work with collections like we are with our items. So let's say we have a list of to-dos. Everybody builds to-do apps, right? And instead of saying with state and giving it an array of to-dos, we can say with entities and give it a type of to-do. And what that's going to do is give us three separate signals. The first is the IDs, the second is an entity map, and the third is the entities. So what that looks like is if you need to get the IDs out of that collection, you just call store.IDs. That'll give us an array such as 1, 2, and 3. If you know the specific ID of something you want to show, you can call entity map and then pass in the ID. So this is great for if you need to get something on your template and you don't want to have to create a separate function that does an array find or something like that. And then if you need all the entities, you just call entities and you get that full collection like you would if it was in the state. What this could lead you to think is, well, what if I have multiple collections? How do I deal with that? And what we can do is, first, got my slides mixed up. You also get a lot of updater functions. We're going to kind of see this in a minute of how this works. But it allows you to really easily manage updating, adding, removing, deleting all these entities without having to do a lot of array functions. Okay, so what I was going to say is what if we have other collections? What we can do is change our with entities to tell it what type it is and what collection we're going to call it. It's just a string. It can be whatever you want. We're going to call this collection to-dos. And instead of IDs, entity map, and entities, we now get 3 different signals that puts that to-dos collection name at the beginning of the word. So we now have to-dos IDs, to-dos entity map, and to-dos entities. So if you have multiple collections, you can just name them. Or if you just want to always name them just to make it more verbose, you certainly can do that. All right, so before we had our items as part of our state, we're going to move that to entities so that we can utilize some of those helper functions to help kind of clean up our code a bit. So on the right, we're calling with entities and telling it we're going to use the store item type. I'm not going to give it a special collection name. We're just going to put it as entities. And then we need to update our template. So before we were saying in our for loop store.items, instead we're going to replace that with store.entities. So very easy refactor to go from having something in the state to using entities. Now, before we had these two functions that we were doing some array mapping to find the ID that we wanted to update and replacing it, and then using the patch state to update the state. We can now use the update entity function. And so we still use patch state like before, pass in the first parameter of the store itself, and then we call update entity. And what update entity takes is the ID that we're going to update, which we already know that because it's being passed in from our component, and what changes we want to make. So this is a partial of that store item. All we're changing here is the in-cart value to either true or false, and that's all it takes. So much cleaner on the right and much easier to read. If you read this left one, you're going to have to parse through the map and figure out what exactly is happening. And then on the right side, you can just see, okay, the only thing we're changing is the in-cart value. Computed signals are one of my favorite things from signals, and it really takes away some of the stuff that we might use RxJS before to kind of react to changes and compute something and get that value. So the way this works is if we have a couple signals here, first name and last name, there's just signals with strings. We can create a computed full name signal, and this will take the first name value, add it to the last name value, put a space in between. And the way this works is it will run immediately and get the value from first name and last name, and any signal reads within the computed will then be tracked. So what that means is if first name or last name changes after that compute happens, it'll recompute and give us a new value. And this value is saved, it's cached. So if you have something that requires a lot of processing and you put it into a computed, and you're using it multiple times in your templates throughout your app, it'll only compute once and it'll be cached and used throughout your application. So it won't run like 10 times if you have it 10 times in your template. So within Signal Store, we have this with computed method. And that first parameter is the store. I'm just using a destructuring to take out the entities that we have in there, all of our shop items. And I'm creating two computed properties, the number of items that are in the cart and the items on the cart, because we need to be able to show which items are in the cart on the cart page, and we need that number for the little badge in the toolbar. We also need to know the total value of everything that's added to the cart. I'd like to reuse the items in the cart computed signal we've created, but you can't do it within the same with computed. It doesn't actually have that available. So what we can do is we can create another with computed. You can have as many of these you want. And from there, now the store that's coming in, that first parameter, has everything including what's in with computed. It's important to note that everything within the signal store, your order matters. So everything, if I move this with computed up above the first one, it'll no longer have access to the items in the cart. So order does matter. And what this does is if our entities change, if we add an item to the cart, both of these computed, the number of items in the cart and the items in the cart are going to see, hey, I'm using that and it's changed. I need to recompute. Once items in the cart has recomputed, the total cart price is going to say, my signal that I'm using has changed. I need to recompute. And we can use computed signals just like regular signals within our template. Just use the parentheses to get the value out of them. Here's the total cart price, just passing it to a currency pipe to display that. All right, async tasks. So signals work in a synchronous manner. But we're used to using RxJS a lot in Angular, especially with like HTTP calls. So how do we work with async tasks? So within our methods where we have our add and remove items from the cart, we could have a new function called load store data. And I'm just going to create it as an async function like you normally would in just JavaScript. And we can use the await and then catch if we're using like a promise-based approach. So in this case, the API.load is using a promise-based, fetching the data, returning it back to us. And we're using that set entities, which is one of those helper functions we got from the entities package, telling it to update the items and set them to that. And then we're also tacking on another updater, which is setting the status to complete. So if you want to break up your updaters, you can do it in multiple parameters within patch state. So if we are using RxJS, there is some interop with signal store. Here's an example from the documentation. The RxJS itself is kind of outside the scope of this talk, but you call Rx method, and then the type is going to be the type of the parameter you're passing in. So in this case, they're wanting to load these books by some kind of search query. That query is being used within the switch map, and that's going to be of type string, which is what we're passing into the Rx method there. Angular is kind of on the road, a very long-term road towards having RxJS optional. So I think we're going to start seeing more promise-based things within like HTTP. HTTP client still uses observables, but I imagine it'll probably go down the path of just using like a fetch type API. Lifecycle hooks are important, of course. Within our store, we need to load this data when we create the store. So we can import the with hooks function from NgRx signals. And within here, there's two functions that you can pass to it. One is on init, and one is on destroy. So if there's anything you need to clean up, on destroy will handle it for you. Again, you get the store instance passed in as the first parameter. And here we're just saying, take the store, call the load store data. So as soon as this store is initialized, we're going to load that data. Custom state updaters just allow us to do a couple things. We can create these partial state updaters, which are just functions that return a partial state. And we can use that within our code up here, like within the thin catch. We can replace that with set entities and set error. It is recommended to use these for updating state because they are tree shakeable. They're also very easy to test because they're just functions. Custom features a custom feature is a cool feature of NgRx. And what it allows us to do is take a group of state or methods or computed signals, whatever, and wrap it into this feature and then use it anywhere. So in this case, I wanted to kind of break up our shop items out of our global store to make it into like a slice almost. So if you have a global store with a lot of stuff going on, this would be a good way to kind of separate everything out so you don't have one giant store in your application. The naming convention here is to start your function with the word with. So like we said earlier, with computed, with methods, with entities. Within there, we're going to return signal store feature. And inside that, you work with it just like a regular signal store. You get everything like with state, with entities, with computed. And that packages it up. And then within our store, we still have our provided in root, and then we just say with shop items. So now when we inject the store, we still have access to all those same signals we had before. We don't have to change our front end at all, like our template at all. Everything remains the same. It also allows us to do a lot of reusability. This is an example from the custom store feature documentation where they created this feature called with request status. So maybe you have lots of different features that all fetch their own data, and we want them to all track their own status, whether if they're loading, they've errored, they've completed. So what this does is it has a state with the request status, which is either idle, pending, or fulfilled, or has an error string. And we get these three computed properties of is pending, is fulfilled, and error. And now you can package this up into little feature stores and use it throughout your application. This example might not be great with the new, as of today, with version 19, there's the experimental resource and Rx resource feature in Angular, which is kind of like a TAN-stack query. But this is just a good example of how you can take reusability and pass it into different stores. There's also Signal State, which is a lightweight version of Signal Store that you can use within components or within services. It still allows you to define your state and have those accessible via signals. And what Signal State and Signal Store both give you is something I really enjoy, which is called deep signals. So within your state, if you have anything that's not a primitive, it's just like a complex object. If you look at the type here of our user state.user, it's going to be a deep signal of type user. If we look at isAdmin, that's just a Boolean, so that's going to be a signal of Boolean. So with a deep signal, we can still access it, where we have on the third line console log user. And that's going to give us the whole object like you would expect if it was a signal. But you can also access each property as their own signal. So if you have a computed property that is going to be tracking one single property on an object, using deep signal like this allows that computer to only trigger when that property itself has changed as opposed to the whole object has changed. And these signals for every property on the object are lazy loaded. So you don't have to worry about like, oh, if I'm not using all these, are there signals all over my application? If they're not being used, they're not ever actually created. With signal state, we still get access to patch state, so you get a real declarative way to updating that data within the signal state. Again, these are a good way to just kind of add some signal state for your components and services. And that's everything. It's pretty straightforward, and I'm happy to answer questions. This QR code will take you to a page on my site that has the slides, a link to the stack blitz with the code example, and also a link to NgRx, the documentation. Thank you. Any questions? Yep.
Yeah, so with your experience so far using signal sort, what are you finding to be like a common mistake that new engineers are making when they're trying to use this technology?
I think the one kind of gotcha that I see a lot of people get caught up on is the order of your store. So that matters. Like sometimes people will be like, "Oh, I'm using with computer. Why don't I have access to this thing that should be in my store?" And it's because it's declared below them. So the order really kind of tricks people up, I believe.
So order as in just good scoping rules, or just order as in order of operations that are used to
Yeah. Let's see here. I'll just pull up this guy here. So like within here, if I were to create a new computed property here, and I tried to say something like store, or so I'll just change this to store real quick. That's going to break everything else. But if I try to say like store dot total cart price, I wanted to use that signal. It's going to give me an error saying that it doesn't exist within our store because it's defined down here in this computed. If I were to move this computed up above, it'll then be available. So yeah, it's just kind of how this. It's a function building an injectable class. So it's that order really matters. Yeah, no problem. Any other questions? Yep.
Not much of a question, but more of a comment. It's honestly beginning to look a lot like Svelte. Like, I'm not sure if you're familiar with Svelte, but they have like stores, and just the computed function alone looks like the same thing as like the $sign operator does in Svelte before. So it's just interesting how they're all kind of, you know.
Yeah. I believe, I could be wrong, but I believe the Angular team worked with, and I don't remember his name, but the guy that actually created this same concept for Svelte. So yeah, they borrowed a lot of ideas from Svelte. They kind of saw what was working over there and wanted to bring it to Angular. So yeah. Okay. You get to hear another talk right here. Yeah. Right. Yeah, I think, just signals in general, even if you don't go signal store, they really get rid of the need for a lot of really complex RxJS code that is complicated and hard to read. RxJS definitely has a steep learning curve. Computed, it's just like, it's just JavaScript. So yeah, it's pretty cool. I'm enjoying it a lot. All right. Well, I'm giving you guys back, I guess, an extra 20 minutes or so. Thank you guys for coming. I appreciate it.